The Middle East and the North Africa region are the driest regions of the world, with only 1% of the world's freshwater resources. In those areas, agriculture represents more than 80% of the total water consumption. Population growth, climate change, increasing demand, and declining supply are among several factors combining to rapidly increase the pressure on water resources. To cope with those threats, an integrated approach to manage the scarce and valuable water is needed. This new approach should consider water, including surface and groundwater resources, but also other non-conventional sources, such as salty water or wastewater, thanks to the technology developments. The use of treated wastewater to grow crops, either for industrial or human consumption, can significantly mitigate water scarcity problems and reduce water pollution, but the practice is not as widely implemented as it should be.
The general goal of MADFORWATER is to increase the level of water security in Egypt, Morocco and Tunisia by enhancing wastewater treatment and the reuse of treated wastewater for irrigation. In MADFORWATER we have two main keywords. The first one is integration between technologies, water management strategies, and economic instruments in order to maximize the level of implementation of our technologies and water management strategies. The second keyword is adaptation of technologies and water management strategies to the characteristics and needs of the specific context where they have to be implemented.
During the first part of the project, the MADFORWATER partners developed a wide range of technologies for wastewater treatment and irrigation at laboratory scale, but the proof of the pudding is the eating.
Therefore, within the project, we tested different technologies at 4 pilots in Egypt, Morocco and Tunisia.
In Egypt, near the Manzala Lake, the MADFORWATER project introduced an innovative technology, the hybrid constructed wetland. The wastewater is being led through hybrid constructed wetland following several steps. At the end, the bacteria digest the pollution in the wastewater, leading to clean water. The effluent is suitable for agricultural production and fish production. The technology is low cost, low maintenance, and easy to operate. Together with the Institute of Bari, Italy, the calibrated gated pipe irrigation technology was developed and tested. This technology maximizes the efficient use of irrigation water. The technology led to a decrease of 10 to 25% in the water use. The application of both the hybrid constructed wetland and the calibrated gated pipe are good examples that can lead to new water management strategies.
Souss Massa, it's a region located in the center of Morocco.
The area is suffering from serious water scarcity. Groundwater is over-abstracted for agriculture, and due to climate change, there is 20% less rainfall.
We are now in the pilot plant that we use for our experimental purposes.
In this field, we are comparing the use of the treated wastewater and the freshwater with added fertilizers, using 2 different irrigation systems. We have the drippers, which is used by the normal farmers in this area, and the calibrated nozzles.
The innovative calibrated nozzles and sprinklers tested in the project's pilot plants were developed by Roland, a MADFORWATER SME active in the field of irrigation equipment.
As you can see in the field, we do have a better irrigation uniformity and a good olive trees development.
So we believe that the reuse of treated wastewater using the technology developed within the MADFORWATER project, as well as the technology of irrigation that has been developed, could have a great impact.
This potential impact is confirmed by local farmers. It will solve the serious water problem. We will resolve the problem of water scarcity, and we will benefit from the nutrients contained in the wastewater. The treatment process that is developed in MADFORWATER by, among others, the Euromarket company can be well applied in decentralized sewage treatment systems, and especially in the developing countries. Based on the operational data of the pilot unit, they have proceeded with the design of a commercial, full-scale system that can be introduced into the market, which is in the stage of testing and verification.
Our company, SK Euromarket, is working in the field of wastewater engineering. In MADFORWATER, we constructed and installed 2 pilot plants in Tunisia, one for municipal wastewater and one for industrial wastewater.
Moving to Tunisia and the 2 implemented pilots. The textile industry is a very abundant industry in Tunisia. However, the industry consumes a lot of water and also produces a lot of wastewater. Also, it is a low added value industry which does not allow big investments. That is why a simple to use and cost-effective technology was needed. In the region of Korba, the textile industry water use leads to over-exploitation of the water resources. After applying several treatment steps, the resin polishing filter removes the final pollution from the wastewater. The remaining treated wastewater has quality that is within the legal norms of Tunisia and can be reused in many different forms.
So the good quality of treated wastewater could be used for the irrigation of non-crop foods, but also could be recycled inside the industry.
Next to the textile wastewater treatment plant, another pilot is located at the wastewater treatment plant in Chotrana. In this pilot, there are 2 stages of treatment. First is the oxidation stage of organic matter, and second stage is the nitrifying stage. The last step is a tertiary treatment, and in this step the water passes through the constructed wetland.
We have a good reduction of the organic matter, a good also rate of nitrification. We can use these wastewater, this treated wastewater for the irrigation, and we have an experimental field in which we implemented irrigation devices. The results showed that we have good yield of at least agricultural and agronomic yield in the field. The cost of this technology are affordable and can be implemented in other African countries. So beyond the actual result of the project, we seek very good impact of all this technology in the African context.
In addition to the reuse of wastewater in the terms of treatment and irrigation, there is the decision support systems that the project is developing to enhance planning and management of water resources in the region. So the project actually is helpful in the sense that it provides decision makers in the countries of the region with these tools to enhance water management in a sustainable manner.
The project also developed an innovative approach for the analysis of water security and of the potential for treated wastewater reuse in the North African context.
So, what did you learn from MADFORWATER?
I learned that water reuse is not only an option but imperative for the MENA region. And I think the project showed that all technologies are available.
Water is a crucial resource, and you have to learn to plan carefully its use and reuse. The reuse of treated wastewater is a very complex task that requires the collaboration of experts from different fields, from wastewater treatment to irrigation to water management and economy. Projects such as MADFORWATER are precious because they put together experts from all these fields, giving a strong boost to the reuse of treated wastewater in the regions where this practice is less implemented. So together we can make it.